Hello and welcome back to another video. And today's video I'm going to share the insertion sort algorithm. And in my previous video, I actually described about selection sort and bubble sort. So if you miss those videos, then please you can watch those videos for like to have a good understanding about bubble sort and selection sort. So this is actually highly beneficial for the CSA undergraduate students. So yeah, so let's jump into it. How insertion sort works. So before have a visual overview about insertion sort, we need to know what is it. So actually, it's builds a sorted array one element at a time, and takes element and inserts at correct position, and also it actually shifts elements to make room and works well for nearly sorted data, and online algorithm can sort as data arrives. Well, so how it works, it actually starts from the second element, and considering first element is sorted, and then it actually compares with elements in sorted portion. I mean, second element actually compared with the elements in sorted portion, which is actually in his left, and then it actually shift larger elements to the right. So it's compared with left sorted elements and sorted, and then it actually shift to the right, like the large element actually shift to the right, and the insert correct element at correct position. So the sorted portion always grows by one with each iteration. So let's consider this short, which is actually 5246 on, and this is actually absolutely an unsorted array. And on the first iteration, as I already mentioned, that we need to pick two. I mean the second element, and we need to compare it with the on the left, the considering five as a sorted. So let's see a visual overview. So we pick element two, and we compare with the elements on his right, on his left, and what we compare? We compare, okay, this element is less than uh, the sorted elements. Yes, then actually we need to shift the larger element to the right. So we need to shift 5 to right. So let's consider, like, we pick 2, so there is a space for 5 to shift. So it actually, then you can see, like, 5 shift to the position of 2 element 2, and you can see there is an empty space for element 2, like there is an space created. Then now we can just insert 2 on the first position. Okay, so now on the second iteration, we actually pick 4, and we consider that on his element 4, all the elements on his left side is sorted, and we should compare one by one on the left. And then what happened, like, we compare 4 with the second element 5, and we found, okay, 4 is less than 5. So we shift 5 to right, and we insert 4 at position 2, because position 2, because on position number 1 it's already like 4 is not less than 2. So we could not able to shift 2 to the right, because it's 2 is less than 4. So then you actually 4 inserted between 2 and 5, and then we pick 6, and we compare with 5, 4 and 2, and it seems it's already sorted, like 6 is not less than 2, 4 and 5. So 6 is in the already in the correct place. Now we pick on, and then we compare on with 6, and 6 move to right, and then on compare with 5, then we shift 5 to right, and on compare with 4, then we shift 4 to right, and on compare with 2, then seems on less than 2, so 2 shift to right, and ultimately 1 shifts all, I mean on To move on to insert on to the correct positions, or we need to shift all the elements to its left side. And ultimately that is the reason I wrote it here, like one shift also inserted at start, and now the magic happened, like the elements now has been sorted. Well, so here is an Python implementation. So this is the task for you to do, like to implement it in a coding, and by your brainstorming. Like if you are able to understand the concept, then you should able to do this coding. So here is an example of JavaScript implementation as well. Well, and there are the time and space complexity. So the best case, the time complexity is big O n when is already sorted, and the average time complexity is big O n square when it actually random order, and when it's worst, then it also the time complexity is big O n square when it's actually is reverse sorted, and the space complexity is big O n, and the stable sort, yes, because it preserves equal elements order. Well, so when to use insertion sort as like a selection and bubble sort, it's actually perfect for nearly sorted arrays, and obviously perfect for small data sets and online sorting like streaming data and linked list. No shifting needed. Well, so when you actually needs to avoid, so when you have a large random data sets and completely reverse sorted data, performance critical apps, and many hybrid sorts use insertion sorts for small subarrays. Well, so actually it's card sorting like inserted position, and big O n is the best nearly sorted data, and stable and online like great properties and hybrid sort. So merge sort I'll dive into details on the next video. So yeah, so thanks for watching, and I believe you now understand the insertion short. And if you like this video, don't forget to subscribe my channel, and see you on next video. And you can put a comments so that I can improve myself. Yeah. So good luck. Bye bye.